got two fractions here. 2 over 3x add 4 over 5y. And these are two separate fractions, and we're trying to get them into one fraction. So what we can do is we can take this fraction here, the 2 over 3x, and multiply it by 5y over 5y. And that will give us 10y over 15xy. And then hopefully on the other one, you can sort of see what we're doing. So in order to get a common denominator, so that will be a denominator that is the same on both fractions, well, we would need to multiply this side by 3x over 3x. There we go. So therefore, we would get 12x over 15xy. And therefore, we have a common denominator of 15xy. So what we can do is combine this fraction to get 10y add 12x over 15xy. And this leads us into today's topic, which is partial fractions. And what partial fractions is about is doing the reverse of this. We're trying to get this fraction here into two separate forms. So let's take a look at some examples. Okay, so I've got this fraction here, the 2x minus 13 over 2x plus 1 times x minus 3. So what we do first is we take a constant, so we're going to call it a, and what we do is we divide that by either the 2x plus 1 or the x minus 3. So it's one of the terms on the denominator. So let's just say 2x plus 1. And then what we do is we add, and then we take another constant b over, and then the other term on the denominator is x minus 3. And then from here, what we can do is we can try to get a common denominator. If we multiply the left fraction, this one here, by x minus 3 over x minus 3, and if we multiply the right hand side by 2x plus 1 over 2x plus 1, then both denominators would be 2x plus 1, x minus 3, giving us a common denominator between both fractions. So let's quickly do that. So if we multiply a by x minus 3, we'll get a times x minus 3. And if we multiply the right-hand side by 2x plus 1, we'll get b times 2x plus 1 all over 2x plus 1 times x minus 3. And essentially that would be equal to this fraction. So now what? Well, if you look at both sides of the equation, the denominator is the same. So forget about the denominator and look at the numerator. So looking at the numerator on both of these sides of the equation, what we can do now, well, we need to find what a and b are. So one thing that we could do is just try and plug values in for x. And if we substitute x equals 3, well, we know 3 minus 3 would be 0, giving us 0 times 8, which would be 0. Right, so it'd be 0. And then if we substitute 3 in for x on here, well, we'll get 7b. And then we substitute 3 into the 2x minus 13, giving us minus 7. And then solving this, we know that b would equal minus 1. Okay, then how would we find a? Well, if you look over here on the b side of the equation, well, what value of x would produce a result that gives us nothing for b? Well, if we substitute minus a half in for x, then that cancels b out. And if we substitute minus a half on the left-hand side of the equation. And then if we substitute minus a half here, so we'll get a times minus a half minus 3. And then we'll get nothing for b. Well, 2 times minus a half minus 13, we'll get minus 14 is equal to minus 7 over 2a. And then quickly solving that, we'll get a is equal to 4. And then what we can do after that, well, we've got this b term here, and we've found a as well. So if we replace a and b with 4 and minus 1 respectively, then we should get our answer. So our overall answer would be, well, a is 4, and we're dividing that by 2x plus 1, plus, that'll be minus 1, so we can just say minus 1 over x minus 3, and that is our answer. Okay, so what about this fraction here? Well, this time the denominator isn't in its factorised form. So we've got an extra step here where we've got to factorise this x squared minus 9. And if you were to factorise it, you would get x plus 3 times x minus 3. So sometimes you would have to factorise the denominator first. Well, the first thing that we need to do, we know if we're trying to split up this fraction, it needs to be in the form a over x plus 3 plus b over x minus 3. And if we try and find a common denominator, or if we multiply this fraction here by x minus 3 over x minus 3, we would get a times x minus 3. You know what you're doing for the b fraction. We times that by x plus 3 over x plus 3. And then that will give us our common denominator of x plus 3, x minus 3. And that is equal to this up here. So what we do now is we ignore the denominator, because the denominator is the same on both sides of the equation. And essentially what we'll get is 6x plus 6 is equal to a x minus 3 plus b x plus 3. Coming down here. So now we need to find our constant terms a and b. We can do this by substitution. So if we substitute x is equal to 3, well, that would successfully rule out a, giving us 0a, which will be nothing. And then substituting the 3 into the b term, we'll get 3 and 3 is 6, 6b. And on our left-hand side of the equation, we'll get 24 is equal to 6b, giving us b is equal to 4. Okay, so what about a? Well, if we substitute minus 3 into the equation, that would successfully rule out b, giving us 0b. So therefore, we'll get minus 3 is minus 6. Minus 6a is equal to minus 12, giving us a is equal to 2. And then putting this all together, well, we know a is 2, b is 4, so we can replace these constants here. A is 2, b was equal to 4. This here is our answer. Okay, so what about this next example here? We've now got 3 terms on our denominator, and it's the same theory in practice, except we need another constant. So this time what we're going to get is a, and this time it will be over x plus, and then we've got our other 2 terms on our denominator. So that'll be b over x minus 1 plus c over 2x plus 1. And then from there, we need to find our common denominators. So we multiply the a over x by x minus 1 and 2x plus 1 plus, and then on our b fraction, we need to multiply this by x and 2x plus 1. And then coming over to our c fraction, we need to multiply this by x and x minus 1. Okay, now we can take all of this and equate it to the 6x squared plus 5x minus 2. And then what we can do is substitute values and we're done. So first thing that we've got this x here on the b term and the c term. So we can say x is equal to 0, and that will successfully rule out b and c. So let's quickly do that. And we will get minus a is equal to minus 2. Therefore, a is equal to 2. All right, what about finding the b term? Well, we can set x is equal to 1, because that would successfully rule out a, and it would successfully rule out c, since there is an x minus 1 term on those sides of the equation. So therefore, we'll get 3b on the right-hand side. And if we substitute 1 in the left-hand side, 9. So 9 is equal to 3b. Therefore, b, 3. Okay, now this is where things get a bit interesting, because we've got to find c. So one thing that we can do is if we take a random x value, so if we substitute, I don't know, we'll say x is equal to 3 into the equation. Well, now we've got a and b, it should be relatively simple now to find c. So you can use any x value you like. So it could be 1, 10 trillion and 4, but here I used 3. And first of all, let's substitute x is 3 into the left side of the equation. So therefore, we'll get 67 on the left. And then, well, we know a is equal to minus 2. So we'll get 2 times 3 minus 1 times 2 times 3 plus 1. And then you should get 28 plus, well, we know b is equal to 3. We used x is 3 here. And then we multiplied it by 2 times 3, which is 6, add 1, giving us 63. And then we don't know c, so that will give us 6c. And therefore, it will get minus 24 is equal to 6c, giving us c is equal to minus 4. And now if we come back up to the top, well, we know a is equal to 2, so we can replace that. So we'll get 2. B is equal to 3. And we know c is equal to minus 4. So we can replace the c and the plus sign, minus 4. And that is our answer. Okay, so there is a final thing that we must discuss, which is what happens when we've got a repeated fraction. And a repeated fraction is essentially when we've got this term here, the x plus 1, but it's squared. So that means it repeats twice. And there is something that we need to do here. So let's write it out in our split form, I guess, or our decomposed form, whatever you want to call it. So we'll get a over x plus 1 plus b over, but then what? So here's the thing with repeated fractions. We don't write x plus 1 again. So this time we're actually going to write x plus 1 squared. So hopefully you can sort of see what I've done there. And then for the last one, as you know, is c over 2x plus 1. And as you know, we've got to multiply both sides of the a fraction. So we got it over x plus 1. So we need another x plus 1, first of all. And we need our 2x plus 1. So what about our b? Well, we've got x plus 1 all squared, so we don't need to multiply it by x plus 1. We only need to multiply that by 2x plus 1. And then on our c term, we've got 2x plus 1. We need x plus 1 squared. There we go. And then equating that to the numerator, 5. And now we start substituting values into the equation. So the first thing that we can do is substitute x is equal to minus 1, since that will rule out the a side and the c side. So on the right hand side of the equation, we'll get minus b. And then if you substitute minus 1 into the left side of the equation, we'll get 2 is equal to minus b, giving us b is equal to minus 2. Wonderful. So the next easiest thing to do would probably be to find c. So if we substitute x is equal to minus a half, well, we'll successfully rule out a and b because of the 2x plus 1. So let's substitute minus a half into our equation. And on the right hand side, first of all, we'll get a quarter c. And on the left hand side, we'll get 3/4. So therefore c is equal to 3. And now we come over to a. So as we know from last time, we take a random x value. So this time I'm just going to say x is equal to 0. And we're substituting our chosen x value, for me it was 0, into the entire equation to find c. Because now we know b and c, and we're finding a. Sorry, I was meant to say a there and not c. So therefore on the left hand side of the equation, we'll only get 5 when we substitute x is equal to 0. And then on the right hand side of the equation, well, if we look at the a side, if you substitute 0, we'll get a on its own. And we know we'll get a on its own, which will just be, well, we don't know what it is yet, so we'll just call it a. And if we look at our b side, we'll substitute x is 0, we'll get 2 times 0, which is 0 plus 1. Well, that would just be b on its own. And we know b is equal to minus 2. And what about the c side of the equation? Well, substituting x equals 0, 0 add 1 is 1, 1 squared is 1, so we'll just get c on its own, and c is equal to 3. And then we do add 3, and then now we rearrange to find a on its own, giving us a add 1. Overall answer, a is equal to 4. Now using 4 minus 2 and 3, we can now substitute our values in. So 4, and then b was minus 2. C was equal to 3. Therefore, this here is our answer, and we're done. So hopefully you enjoyed the video. If you found it informative, please give it a like, and I'll see you in the next one.